Today, I'm really excited to welcome Professor Kilian Weinberger to the podcast. He's a professor of computer science at Cornell University, where his research focuses on machine learning, AI, computer vision, and deep learning. His work has contributed to many important modern machine learning areas, including metric learning, representation learning, and large scale machine learning systems. He completed his PhD in machine learning from the University of Pennsylvania and his undergraduate from the University of Oxford. Over the years, Professor has received multiple Best Paper awards. Beyond research, he is also known as exceptional teacher teaching popular machine learning courses. I am really looking forward to discuss his journey in machine learning, his insight about the field, and what the future of AI might look like. Professor, welcome to the podcast.
Hello, Pratik. Nice to meet you.
Okay, sir. So to begin this podcast with, let me begin with the starting point of your life. When you were a child, what did you imagine becoming? Was academia always on your mind? Please share that part of your life.
Uh, it's a good one. So when I was very little, I think I wanted to become a clown or a comedian, actually. Uh,
Okay.
but I'm not sure if I was funny enough or, brave enough to go down that career. Um, but my parents had a friend who was a professor at actually the one of the universities in Munich, and they always I kind of noticed how they always respected that person a lot,
Mhm.
and that had made an impression on me. Like somehow, like I was like, when I want to be older, I want to be like that guy. Like everyone, everyone respects him. Like he when he says something, everybody listens.
Yes,
And
yes.
so that had certainly had a big influence in me. So it was always, it became kind of this dream of mine. It wasn't clear if I would achieve it. It seemed like a very hard path to get there. Somehow it did work out, but it was from some age on, it was in the back of my. It was kind of this dream that I had. That's probably fair to say.
Yes, yes. And actually, many of us in India love your teaching that I would like to tell you.
Thank you, thank you.
Mhm.
That is actually one thing I do really enjoy teaching. It's something I really like doing, and it was certainly one reason why I went back. But I was in industry for 2.5 years, and I really liked industry. It was fun, but I missed teaching. Like that was somehow one of the aspects. I felt like one thing that's nice about being a professor is it wraps up all the things that I like doing, like research, mentoring students, teaching, and so on. So.
Yes,
Uh,
yes. Now I would like to go towards the time when you were doing your undergrad. During your engineering days, when did you first feel pulled towards machine learning? Was there any particular course or something else? Can you share that with us?
and yeah, it was more dumb luck actually than anything. So when I was an undergrad, you mentioned earlier, what was the University of Oxford? There was nobody there, I don't think, who did AI or machine learning. So I didn't take any classes in it actually. Like I as an undergrad, I wasn't involved in research. I just took classes and um, actually, at the time I did mathematics and computer science. Like it was a joint major. It's called mathematics and computing. And I actually thought I was gonna try to do a PhD in mathematics. And I really liked discrete math and abstract algebra. I thought it was very beautiful. And then one day, actually, I asked my tutor. So Oxford has this tutoring system. So you have these tutors who basically advise you. And he was a professor in abstract math, and he was basically, in some sense, my role model. And I asked him if he went to this conference actually in Israel, and there was like some something going on in Israel, and I was like, well, if a bomb goes off and everybody at the conference dies, like wouldn't that be a total disaster? Like everybody, all these experts would die, and he'd
Mhm.
be like, well, yes, but I don't think anyone would really care. Like it's not, you know. And I was like, well, um, so I asked him, like, when you write a paper, how many people can read your paper? Like, And he's like, oh, it's more than you think. I mean, it's at least 5 people. And I felt like, well, I don't know, isn't that, I don't know, somehow that didn't speak to me. Like doing research that only maybe 5 people can appreciate. Like somehow it seemed like so small. I was like, well, why do I have to go to a conference? I can just write them a letter or something. I don't know. And so I fell out of love with that area. And I decided maybe I should want to go into computer science. It seemed more applied and more useful. And and then, to be honest, I just watched sci-fi movies and I liked AI and I thought it was cool. And so it was very naive, actually. And when I went to UPenn, and when I applied to grad school, I only got to one place, actually. I only got into UPenn. That was the only place. I probably could have stayed in Oxford, but it would have been mathematics or something. Um, and so when I went to UPenn, I basically, liked working with my advisor, Lawrence Saul. And I was very, very lucky because he was doing very modern machine learning at the time. It was optimization-based machine learning. And so I just jumped on this bandwagon. I had no idea what was the right path and what was the wrong path. And so
Yes.
I was very lucky that he was someone who was basically at the very forefront of what machine learning was at the time. And so I started going to NeurIPS, ICML, and so on, and met all the other people who were kind of in that field. And so very soon I I was in the thick of it. But it was really I think it was more luck than anything, actually.
Mhm. Yes, yes. So, sir, earlier in one question, you mentioned that you have worked at Yahoo. So, my this question is particularly related to that. You have spent enough time at Yahoo. What did that experience teach you, and what made you return to academia to create impact by teaching?
Yeah, Yahoo was fun. It was really, really fun. It was a research lab. I really liked my colleagues. It was great, actually. I worked very closely with one guy, actually, particularly Olivier Chappelle. Um, Sadly, he passed away a few years ago, but he was a fantastic mentor. I really have nothing but good things to say about Yahoo research at the time. Um, one thing I found is that um, at, what I found like industry was great, but what I missed was like there was no teaching. So I actually started teaching in class internally, like within Yahoo. Um, and I liked working with interns. So I didn't have students, but I liked working with interns. And so in some sense, I try to make it a little like academia. Um, but at some point, I felt like, well, academia is kind of was always my dream, as I mentioned earlier, and it seemed more what I wanted to do. The other thing was also that in research and in industry, I felt like at some point there wasn't a path for me anymore. What I mean by this is you do research and you really enjoy it, it's fun, but it wasn't clear where to go. Like you could either become a manager, but if you're a manager, then you're managing people and you're not doing the research anymore. You're managing other people having all the fun. So that didn't seem like that's what I want to do. Um, but on the other hand, there wasn't really a place to grow, really. Like in academia, you kind of build up a lab and you get postdocs and students and so on. Um, and after 2.5 years, I felt like I wasn't sure what to do next. Like am I going to do this for the next 30 years? Like am I going to stay in the same position and do exactly the same thing? And somehow that I couldn't really see myself doing that. Um, but it was fun. It was great. I just and to be honest, it was also very, very, having been in industry was very helpful early on when I became a professor,
Mhm.
because when you in the US system, at least, you go up for tenure after 6 years, and then you either get basically laid off or you get a permanent position. And this can be very stressful for a lot of people. And for me, it never was, because I always knew, well, if I don't get tenure, I just go back into industry, and that's not so bad. I mean, that was fun too, right? So it's not, you know, I feel like that experience was really important, such that my, you know, faculty job then wasn't as stressful.
Yes, yes. Your journey is actually very inspiring.
I don't know.
So, sir, before I ask my next question, I would like to share my personal experience with you. Whenever I get a doubt in my machine learning syllabus, I usually do one simple thing. I go to Google, type that topic name, space, Kilian Weinberger, University. When one of your vlog or video shows up, what I really like about them is it start from very basic and build intuition step by step, written in very systematically manner with clear visualization. Many of my doubts of my students I have cleared just by reading your articles. So this brings to my next question. What does it take to become a great teacher? Specifically when we are teaching subject like machine learning, which is mathematically very deep, but also very intuitive. Can you please share?
Yeah, I don't have a good answer for this. And I mean, to be honest, I really like teaching, but I have many times that I teach and I afterwards go like, ah, that was not good. I walk home and I was like, that was a terrible lecture. Like, I wish somehow I didn't get it across. Like, for me, teaching is a little bit like a puzzle. You know, you have something and you're trying to explain it. And how do I explain it with the tools or with the concepts that the students already understand, right? And it's always somewhat tricky, and even actually sometimes like concepts that I've already taught many times, like I still sometimes screw them up, and I walk home and like I could have made it so much clearer. Somehow I didn't make it clear. Um, so I don't, you know, I can only see how I perceive it. So it's basically this, like trying to make it so clear, even in my own mind. Right? Like I feel like actually there's this thing that when you think you understand something, and then you try to teach it to someone, and then you realize that you yourself didn't really understand it. Actually, I don't know
Yes,
if you ever
yes,
had that experience.
yes,
It's
yes,
like as you're kind of trying to explain it, you're like, actually, that doesn't really make sense what I'm saying, right? And
yes,
so there's this first process of trying to make it really clear in your own head, right? And um, I actually had this when I was at UPenn. There was this professor, Dan Lee. He's actually now a professor at Cornell Tech, and he was someone like he taught a class called machine learning for robotics. And I remember that every time he explained something, it was so clear. Like it there wasn't even like he just explained it, and it was just so intuitive that there wasn't even a question like why was that why did I ever think that was complicated? And um, it's this point of clarity that you need to reach to explain something, but it's not easy. And sometimes you can stand in front of a crowd and then you kind of confuse yourself. um, so I try to do that though. That's basically I'm trying to kind of make it so clear in my head that I can explain it in very simple terms and in very simple language. And then I try to relate it to some experiences that the students have. Like, how can I kind of make some analogy that's somewhat clear? Like, it, you know, what's very confusing is if I use words that they learn in this class to explain concepts that they learn in this class, then you kind of learn the language and the concepts at the same time. And I think that's very confusing. So, one thing I try to do is try to somewhat use examples from their own lives or something. It's not, I know, it's not always easy or possible, but when I can, I try to inject it. So, you know, that's basically what I do. Sometimes it works and sometimes it doesn't work.
and when it works, how do you feel, sir?
And then I feel great. And then I actually, it's like there's nothing better than actually when I explain something and and I was like, wow, everybody got this. This was really
Yes,
good,
yes,
right? And students come up to me afterwards and go like, now I finally understood this. So sometimes it really works, and then that's a very satisfying feeling. I agree. That's
yes, yes, yes. I also, uh, I also can relate with what you're saying. Many times after delivering the lecture, we somehow understand how it should have been delivered. After making the lecture, we understand, okay, this concept should have been delivered this way. It would have
that's
been
right.
more
That's right.
better.
That's right.
Mhm. Mm.
Yes, I resonate with that. Like once it's right after teaching, you realize, that really didn't work. But now I know how to do it. And then
Yes,
actually
yes, yes.
sometimes I take notes. I call it note future self, and I put them in because actually the worst feeling is when you give a lecture and during the lecture you realize, oh no, I should have done it this other way. And last year, I also did it the wrong way. I had the same realization in the last lecture too. So because you're only teaching the same lecture once a year, you really, I really have to take notes to myself and kind of say, but next year, don't make that mistake again, right?
Yes, yes.
Try to explain it from this angle. That's much clearer or something. Um,
Yes, yes.
so it
Okay,
also
so
sometimes takes a few times to make it clear in your own head.
yes, yes. Few practice. It is like a performance. Teaching is like a
Yeah, yeah, it
performance.
is. That's right. That's right. Yeah, yeah.
Yes, yes. So now, sir, I will ask you very general questions which can help students in India to make a strong career in AI field. Since, as we know, there is a rapid advancement in AI, I want to ask you two questions. First question is, how important is mathematical depth right now in machine learning? And also the second question followed by it is, how do you see the roles of programmers is getting evolved by the rapid advancement of AI?
Right. So mathematical depth, I don't think is as important anymore as it used to be. Not even close, actually. Like it used to be that basically there was this view that certainly in the 2000s that now finally we have a theoretical underpinning that kind of all of machine learning stands on, and we really have to understand this theory and that advances would come from theory, and that actually essentially hasn't really held up, right? Advances now very empirical, and um, yeah, I don't think it's my homepage. I think I still have written. If you want to join my lab, still have to have a very strong mathematical background. I'm not even sure if I believe that anymore. Actually, I think it's not that true. Um, I certainly my papers are much less mathematical these days and much more empirical. Um, there's still there's still like you shouldn't if you don't know any math. I think it's problematic because it still stands on some mathematical concepts, but it's just not as critical anymore. I forgot what was your second question.
Second question was about role of programmers way it is getting evolved. Because many of us say like programming is just like a simple language these days because of various AI tools.
Right, right, right. Yeah, I use Cloud Code all the time. I gotta admit, I think it's amazing. Um, and the I hear, one thing I hear a lot is that companies now don't need as many junior people. At least that's what they say because they basically say, well, now senior people can code again, and they know much more what they want, and all the stuff that junior people did for them. In some sense, they now use cloud. That's probably true. I didn't have much time to code anymore in the last few years. Now with Cloud Code, I can suddenly code again because it's so fast. I can just sit down on a Monday night and just think, oh, I want to make a demo for my class, and it's just I know exactly what I want, and I can describe it, and then Cloud Code implements it. That works. Obviously, this doesn't. The strategy of the company is to not hire junior people. Is not going to work, right? I mean, it's not going to last. I mean, senior people will die, right? And then you need
Mhm.
new people. So it's that's just a short term
Yes, yes.
phenomenon. So there will be a hiring spree, I would say, sooner than later. Um, it's also that right now there's uncertainty on the market. So when there's uncertainty, companies stop hiring just out of caution. And I do strongly believe this will reverse itself, and actually there will be a big hiring boom soon. I also do think that there will be a change of generations. That junior people will be more and more, adapt with cloud code themselves, and actually, or whatever coding AI you're using. Um, and I think what will change is more that. the expectation of what a single person can achieve will move up. Right? This idea of, oh, AI will do everything and we're just going to sit around and eat bonbons. I think that's not, I don't see that happening. Right? It's a little, if you compare, for example, I grew up in the 1980s. And if you think about computer games back then, like Donkey Kong, I don't know if you know these games, right? Like these early computer games, it was actually very hard to write them because they were all written in assembly, right? And they had to be extremely optimized. These processors could do very little, they had very little RAM, right? And so it was a huge amount of undertaking to write a game like Donkey Kong, right? And at the time we thought these games were amazing, like Pac-Man, right? Like I remember as a kid, I was like, "This is incredible!" Like like graphics cannot get any better. I mean, look at the guy in Donkey Kong. He has a mustache, he has pants, he can see everything. It's incredible, right? Like nowadays, if I show this to my children, they're like, "This is pathetic," right? I mean, and so, but it's so what happened is, well, coding games became much easier. There's now libraries, there's GPUs, there's all the stuff, right? But what happened? The expectations went way up, right? I mean, now games have to have actually voice from actors, and they have cutscenes and so on, right? 3D graphics, right? So I think that's the same thing that will happen with programming too. That beforehand you could just make a command line tool, but you just say, okay, here's my tool that I programmed, and you can just use it in the command line. You say dash whatever. You have a long, complicated command line. Read the instruction manual. Whereas soon that will not be acceptable anymore, right? Soon you need an interface, a graphical interface. We can drag and drop files. It has to work in dark mode. It has to work on Linux and Mac and Windows, and so on. And Cloud Code will do all of that automatically for you, right? So actually, I just a few weeks ago I coded up a little demo for my class, and it worked. I was quite, I used Cloud Code to build it. It was actually a tokenizer demo. But the interesting thing is that it automatically worked on cell phones, and it worked in dark mode. And this is something that I hadn't even considered, but Cloud Code had done it automatically, right? I mean, this is something, it just shows that the expectation of what you can produce is much higher, right? And somehow it's also so easy to do that now.
Mhm.
Does that make sense?
Yes, yes, yes.
I'm
Yes, you
also
can continue.
consulting like for a company right now, and we do a lot of AI in that company. And I see exactly this, that basically now a single person can just produce in a week what used to take, the whole team maybe several months. But it's not at all that we are hiring less now. Actually, we are hiring more, right? Because actually now we are so productive, we actually, we're getting market share, So it's actually things are looking up, right? Looking great. And so that only leads to us hiring more people.
Mhm. So my next question is related to this only, sir. Like there is a saying in AI that AI will not replace us, but people who use AI will replace job. Still, I have a question about the future. As AI keeps getting improved and getting trained again and again inside the companies, it may start understanding how work is done in that organization. So after some time, AI might be able to do many tasks on its own. In that situation, do you think the number of jobs will get reduced? And how do you see the role of humans in that kind of future?
Right,
Because
right.
because AI is getting trained on a huge amount of data.
Yeah. There certainly are jobs that will go away. I mean, that's always with technology, right? For example, you know, drivers, certainly in Western countries, I was just in Austin, Texas, actually last week, and one thing you see everywhere there is taxi cabs, right? They're basically, like these Waymo, automated Waymo robocabs, um, driving around everywhere, and so it's probably a bad idea to now think your career is going to be a driver. Um, sooner or later that will go away. Different places sooner. You know, um, Austin, Texas, of course, in a sunny place where there's no snow, so that's gonna, you know, um, happen faster there. But these things, are not great careers looking forward. But that's always existed, right? So, I would also not recommend anyone to work in a coal mine right now, right? That's going away. There is uncertainty, that's for sure. right? Especially things are moving so fast, where, you know, what jobs are going to be the ones um, that go away is not entirely clear, right? And it's very tragic when it's a job for which you need a lot of training, right? So I could imagine, for example, dermatologists, right, to be much less relevant because, if you, for example, check your skin for moles, well, I could imagine some machine where you just walk in something like a shower or something, right, and just takes a picture of you from all angles and tells you which moles to look at, right? And so that takes away a big part of what dermatologists do, and that's tragic because that's a job that you need many years of training to get there. Um, but who knows, right? Maybe it will just shift what they do. Um, with coding, I it's it's really unclear to me. It could also be. I could imagine that software in future will be self-modifying. That you have something like Microsoft Word, and you ask it, "Can you?" I mean, actually, I'm pretty sure that this is going to happen. But you can just ask it to have new functionality that you want. You describe it, and then it changes its code. The first way of doing that basically would be through Visual Basic or something. You just inject some macros or something, right? I mean, essentially, they can already do that. But uh, to what degree are humans still needed? Uh, there's an argument to be made why we still need humans, and that is because ultimately, what we do is we make products for humans, right?
Mhm.
And only humans know what we want, right? There is so and only we also go like, what do humans want? We don't even know what we want, right? It also changes all the time, right?
Yes, yes,
Um, like what's fashionable right now at this moment, right? And so that's something
yes,
that's hard to predict because it's, I mean, almost impossible to predict for an AI because it's not, it doesn't know, right? It's very irrational, right? Um, and so I think this connection with humans is still very important, and that won't go away. You need someone to translate, uh, what do systems do for the market, that they are designed to cater towards. Um, yeah, I don't know. Does that make sense? Uh, uh, yeah, it's a little like, when you people ask me about art, right? Can AI create art? And I think I don't know if you know Kafka. Kafka is like, this famous Czech writer, and he wrote these beautiful parables, like that are very short stories. And now that they're out there, everyone can write something like him. Like it's almost like a formula. But what was so amazing at the time was he was the first one to do it, right? And when people read them, they had, what was so amazing is that he has these very short stories in which he encapsulated a feeling that humans have. Like he felt a certain way, he felt trapped in his life, and he managed to write, you know, short stories that encapsulated that feeling. And when people read this, they suddenly resonated with it and they could understand how he felt. And that was basically this amazing thing, right? That he expressed something that you couldn't really express in language, or not in a direct way. He expressed it in an indirect way in language. Um, and I don't think AI will ever be able to do that, right? Because you need to be human, because it's a direct communication between one human and another. Um, and so that's that human element that's missing. And the reason we need it is not because humans are smarter, right? I think AI will be much smarter than humans, but it's because at the end we care about humans, right?
yes, yes.
That's the important thing.
Also, sir, one more question is there. This is related to the syllabus point of view. We keep seeing new architectures, new models, new techniques. So many of our students are very confused that whether there is actually important to learn classical ML algorithms now, or we can directly shift towards deep learning or advanced machine learning. techniques?
Yeah. So I actually, yeah, I always have to be careful. It's always a mistake to, it's very easy to fall into this trap that the old stuff, classical stuff is important. But I actually do think it is. Maybe not everything, but ultimately, when you think about deep learning, um, it is, first of all, it's built out of the building blocks of classical machine learning. I mean, if you look inside of deep learning, it's just, a neural network, it's a logistic function, as, it's all the same tools. And one thing that's very important is to understand that none of this is God given. Like if you just learn this, if you now just learn deep learning, right? There's this, I think, this mistake of, oh, this is how they have to be, right? This is, or the transition function has to be a ReLU or something, or and there has to be an MLP, and there's an attention layer, and then there's an MLP. Attention layer has to be this inner product based stuff. No, not at all, right? It can be totally different, right? And it could be different building blocks, and we have to make sure that we don't corner ourselves into a very, very specific way that algorithms work, right? And actually, that's the mistake a little bit that we've gone through that mistake, right? In the 2000s, there was a time when basically everything was SVMs. Support vector machines were everywhere, and machine learning became this thing. Machine learning is almost, equivalent to optimization, right? You just formulate an optimization problem, and then you do a solver, and it has to be convex and has to have constraints. You just write down all these exact specifications of your optimization problem, and then you solve it. And then, deep learning came along and just blasted that wide open. And I think that's, in part because people did not forget the old stuff, which was neural networks, right? And basically gave it a second chance, tried it, right? And had never, actually, some people had never given up on it. And I think we have to make sure that we don't repeat that mistake. Back then, that was the same thing. Like, should we even cover neural networks in class, right? Like, it's so outdated. Nobody uses them anymore. Is this worth it, right? And in hindsight, yeah, the answer is yes. It
Yes,
was
yes,
probably important to still cover it. So I think the same thing still applies, right? And
yes.
especially when you have, these are all just building blocks. I mean, people 20, 30, 40 years ago were just as smart as now, right? They just had different constraints, right? They had different compute, different, opportunities. And so they developed very elegant solutions to very specific problems. And if these problems come now, actually, it's good to know how to solve these. Yeah, in particular, because you may want to develop a different architecture one day that actually uses different parts. For example, you want to stick a kernel maybe into a deep net, right? Certain people certainly tried it on multiple occasions, right? It can help.
Mhm. Yes, yes. I think it was the time when electronics was not that advanced when you have stopped using neural network.
Yeah, yeah. Certainly, machine learning has a long history of being essentially following Moore's law, right? So
Mm-hmm.
always constrained by compute. And initially, neural networks were, not as efficient as for example, support vector machines. Like if you have a one-layer neural network, it tends to be better to actually use a neural network SVM. If you can do multiple layer deep nets, then they get an edge. But that's, you have to do very fast matrix multiplication, and without a GPU, you couldn't really do that.
Mm-hmm.
So who knows, like if Frank Rosenblatt would have had, when he invented the multi-layer perceptron, if he'd had some GPU, supercomputer, right? Who knows what he could have done, right? But that's just the way it is. And I guess ultimately, you're right. But what won in the 2000s was basically, it turned out that SVMs are not very good at absorbing computing power, whereas neural networks are very good at utilizing computing power. So
Mm-hmm.
it seems like that's what tends to be
Mm-hmm.
winning, is whatever can use the compute that you have at the time.
Mm-hmm. So, Professor, before we wrap up, I would like to ask you one last question. During your research career, you must have worked on many interesting problems. Is there any research project that you would like to share which was very interesting at the same time very challenging too? Any learning from that which you can tell to my students?
Very interesting, very challenging. Well, uh, I can certainly remember when I was a PhD student, I worked on the paper called Large Margin Nearest Neighbors, which then, basically at the time, we had this idea of kind of writing, like learning representation of data and writing points as triplets, which I think then eventually evolved into the triplet loss that people still use today. And the idea was basically you have a data point, you have a data point of the same class, you want those to be close, and a data point of a different class to be far away.
Mhm.
People back then didn't think about representation learning. That was not really a thing. And I, I worked on this and I tried to write it as an, optimization problem. And it was very, very challenging. Like, and I basically, and the reason was because I could show it was a semi-definite program. But this was when people didn't really use SGD. And so it took me like several months to basically come up with a solver that could actually solve that problem. And so every single week, basically, I was like, am I ever going to solve this? Right? Is this going to work? Basically, I could solve it, but only for 100 data points or something. And I knew that nobody would care if you can do it for 100 data points. And I really wanted to do it for MNIST, which was at the time a large data set, 60,000 data points. So I knew that the only thing people would pay attention to this is if I can scale it up to, at the time seemed like a large data set, 60,000 data points. And I ultimately had to write this and used MATLAB, but I had to write these C functions and had to compile them into MATLAB. And I had to really take everything apart and really kind of, it took me such a long time to really make this work on a computer of the time. And my advisor always reassured me, like, oh, but Kilian, it has to work, right? Like every time I went to him, it's like, I don't think it's gonna work. And he's like, Kilian, it has to work. Like, just look at the math, right? It has to work. Like you just haven't found the way, but don't worry. And so, I went back and I tried, and then next week I came back to him. I was like, I can't figure it out. And he's like, you're gonna find a way. Just keep thinking. Like just the derivation shows that this has to work. And then eventually, actually, it started working. And we published it in Europe. And the interesting thing is that two things happened. So one thing happened when I presented at Europe, there was another student who I then became friends with, but he actually said he had worked on exactly the same problem. And he actually, and we talked about it, we exchanged notes, and it turns out we had exactly the same idea. But he actually, at some point, basically stopped and gave up, and basically said, like, there was one barrier that he couldn't overcome, and he just gave up. And I talked with him, was like, oh, here's how you get around this. And he ran up to his hotel room and, just coded all night. And the next morning he came down and he was like, oh, yeah, you're right. Now it works, actually. Right? So it just shows you that basically if you get stuck on something, that can actually be a good thing, right? Because actually it holds up, it's like a wall actually is what stops other people, right? And you have to overcome
Yes,
that
yes,
wall.
yes,
The other thing is also years later, I asked my advisor, like, how did you know that, this was solvable, right? Like, how did you know that actually there was a solution? And he was like, oh, I had no idea. I just wanted you to keep trying. and ultimately, he was right. Like he hit the right gamble. But it just shows that you just gotta, like, in order to really solve something, you have to really go deep and really, really not give up. And I've certainly had this later on, where I had students who kind of gave up too soon, and then someone else published the paper and went further, and it's a very painful experience. So I guess the trick is to really kind of really dig deep. I guess that's what I learned that from that project.
yes, yes. It was very wonderful talking with you, Professor. And I believe that many Indian students are going to love this video. I again want to thank you for all the blogs, whatever you have written, and all the videos which you have created for machine learning. They are fabulous, especially
Thank
for
you very
our
much.
syllabus. It is very
And sometimes I
fabulous.
get emails from students in India actually, and it makes me very happy to know that it's actually useful. The I actually put them online uh, because I had them internally at Cornell on a server behind a firewall that a student could actually watch my lectures if they miss it. And then one day they shut down that server, and they only gave me a 2-day warning and saying, "Oh, we're shutting down that server." But I told all the students that class is optional; they can always watch the videos. And so I just put them on YouTube. And I was surprised that suddenly people from outside Cornell actually started watching it and asking me questions and so on. So it was very satisfying actually. It's like, it's like very it's good to do something useful, I guess.
Actually, I have created one machine learning cheat sheet, which is very famous for GATE exam. All the content which I have kept in that machine learning cheat sheet is all your material itself.
Oh, that's great. That's great to hear.
That helpful it is. Thank you, sir. Thank you for your time.
Thank you so much for the interview. It was a lot of fun.